Hey Pascal, how you doing?
Hi, I'm good. Thanks for having me.
Yeah, great to have you on our show. I heard that you want to talk about Terraform today, and that's new for me. I've worked with Bicep and I've worked with ARM templates, and I've done a little bit of Pulumi, also one of the languages and tools you can use for deploying stuff. But Terraform is new for me, so I'm very curious. I would say take it away.
All right, I will do that. Thank you. So, indeed, we are going to talk about Terraform. And, let's dive in. First, an introduction. So, Terraform is a technology to provision your infrastructure as code. This is one of the most important facets of DevOps. And at the end, DevOps is meant to have faster software delivered, more reliable and cheaper. So infrastructure as code is one of those important pieces of that. Terraform is created by HashiCorp. It already exists since 2014, and it is known for its cloud agnosticy. Um, but many people think different about this. So what this means is we are going to create, you can create templates for Terraform, but you can't use the same templates for both AWS, Google, and Azure, for example, but you can use the same technology. So you have to create separate templates. I really like the documentation of Terraform. It is extensive, very detailed. Actually, it is better than the Azure documentation for Microsoft. So, for example, when I need to know something about AKS, when one property is needed, when another is filled, then you can look up the details in AKS for Terraform. Of course, an open source framework technology that needs a big community, and Terraform has it. You can see it based on the number of questions on Stack Overflow, but there are also, for example, a lot of books written about this, also around Azure. So this says something about Terraform. If we are talking about Terraform, its key features, well, there are a few. First, the state file. Terraform is using a state file. I will begin my demo shortly, and I will tell you what the advantages and the disadvantages are of the state file. Next to this, Terraform is, well, dependent on the open source community. So when one of the clouds, Microsoft in case of Azure, releases a new feature, you have to wait till this open source community releases this new feature. Mind that you're not dependent on people working from home on the open source community. Also, Microsoft teams are working to create Terraform templates. Really powerful is the execution plan of Terraform. The execution plan shows the differences that Terraform will apply to your infrastructure. And I will show this during the demos. If you are going to write Terraform templates, you are going to write human-readable code in a domain-specific language called HCL, the HashiCorp configuration language. It looks like JSON, and well, you're going to see it in a short while. Terraform is using a plugin model. They call it providers, and based on this model, they can support multiple cloud providers, but not only the cloud providers, that's only a bit of everything that Terraform supports. So here, this is just a screen dump from the provider page on the website of Terraform. And we can see here that the six big clouds are here and Kubernetes, but there are also other providers. Actually, everything that has an API uh, can be supported by Terraform. So for example, also Azure Active Directory, Azure DevOps, there are a couple of here like Helm, but also to request your certificates, for example, from Let's Encrypt. It's just, yeah, right behind this. There are a lot of providers. This says there are almost 1900 providers available for Terraform. So this is really massive. So let's begin. I have installed the Azure CLI and I've installed the Terraform CLI. We will move to Visual Studio Code, and there we're going to start the demo from scratch. So I have created this file, the demo.tf, tf for Terraform, and let's provision a little bit of infrastructure to Azure. And let's begin with a resource group. I created some code snippets, so you don't have to look at me while I'm typing. And we are going to provision this resource group. How does this work? There are a couple of keywords that you have to know if you use Terraform. Resource is one of the most important ones. So we are going to provision a resource. That means the Terraform will manage this resource. In this case, from the Azure RM provider, the resource group. Then we are going to give it a name. Let's say RG for resource group. This is not the name of the resource group because that name is, in this case, dotnetFlix in West Europe. Now, this is just a name which is known within Terraform. It is important for the state, which we'll see later on. So is this everything that we need? Well, we have to configure the provider as well. So we have configured the Azure RM provider, and this is enough. So let's initialize Terraform. That's always the first thing that you have to do because this is a new directory. What it's doing, based on the Azure RM provider configured here, it is downloading the correct version of the Azure RM provider. So now we have access to it. Terraform has been successfully initialized, so that is good news. And now we are able to apply our infrastructure. What is Terraform doing at this moment? It is creating this Terraform state file. This contains the state that Terraform needs and will store its state for our infrastructure. So this takes a couple of seconds.
So at this point, Pascal, is Terraform already looking at your Azure subscription?
Yes, it is. It is validating if this resource group already exists,
Right.
that kind of things.
So what do you have to do to tell Terraform about which credentials and which subscription to use?
I have logged in with the Azure CLI. That's everything that is needed at this moment.
Okay. So then it just uses the selected subscription from the Azure CLI.
Indeed.
Yeah.
Yes.
Nice.
Yeah. And in the meantime, we are seeing the execution plan that I was talking about. This is a summary. So Terraform will add one resource, and in this case, the Azure RM resource group with the name RG, and these are the properties. Some are only known after applying. So we tell Terraform to provision this. We are fine with this. It's always a good idea to verify the execution plan. And then when this is applied, well, we have a resource group in Azure. I will not going to show the resources in Azure because that is not important for now. We are focusing on Terraform now. At this moment, I've specified both these configurations in one TF file. That is not necessary. Terraform is looking in the whole directory, so I can create as many TF files as I want. One file per resource, for example, or the provider in a separate file. That's all fine. So we have our resource group now, and let's continue. We want to have more resources, of course. For example, a storage account. So this is the same story. This is a resource, so Terraform is managing it. Again, from the Azure RM provider, and in this case, a storage account. I gave it the name storage and filled a couple of properties that are needed for a storage account. Let's also change one of the resources, the storage, the resource group. We'll add some tags, and we have now a change and a new resource. What we can also do is make use of an existing resource. So for example, I have configured an Azure Container Registry already. And this time I'm using a different keyword because I don't want Terraform to manage this resource. I just want it to read the resource. So then you use a data. The rest is similar. If we want to apply a role assignment to this container registry, well, we can do it like this. So now I've looked up my ID. This is for my user. I'm giving myself full rights. And here I'm referencing the data block that we are seeing here. So this data, then Azure RM Container Registry, the name, and from this registry, I want to use the ID, the resource ID. We saw the same here. So we had a resource group here, and for the storage account, it will be provisioned in the resource group. For a resource, that's the default resource in Terraform. So you don't have to specify a resource in front of this. It's just the Azure RM resource group. Which one? The RG, there could be multiple. And I want to use the name here. The same goes for the location.
So Pascal, when you type this in, do you get like code completion?
Yes, you get code completion if you install the Visual Studio Code extension for this.
Okay.
Based on this, Terraform knows the sequence to provision the resources. So we have added some resources. Let's apply this again. And let's see what Terraform is doing with this. And there he goes. So this is the summary again. He is going to add 2 resources and change one. Well, that is correct, but we can check it to be certain. So what do we see? We are seeing that the resource that is being changed is the resource group with new tags. This tilde means that he's going to change it and he's going to add 3 tags here. Then we have a new role assignment. That's correct. So he's making use of the existing Azure Container Registry, and he's going to create a storage account with a lot of properties. So yes, we want to apply this. In the meantime, I'm going to extend this template. For example, I don't like this ID here. Although the situation that I have created here is not possible with Bicep. So this is something that Terraform is just able to do. With Bicep, this is impossible. You have to create a separate module in Bicep. And that's because that's the way ARM works. So you need a different deployment because ARM templates wanted to have it that way for an existing container registry. In this case, I don't like this ID here. So let's change the way that this works. Therefore, I'm going to use an existing user, myself. So this is my user, my name. Because it is an existing resource, I'm going to use a data block. And in this case, the Azure AD user. This is a different provider. And I'm giving it the name user. If we need a new provider, let's configure this provider here as well for Terraform. And now we can remove this ID and we can say data, and here we have the IntelliSense. Yes, I want this user, the object ID. Well, actually, I have not changed anything, but I have added a new provider, and I removed IDs that I don't want to have in my code. So if we are going to apply this again, then we will see this in this case, when you forget to initialize Terraform, because I've added this provider, Terraform will notify you. So that's very handy now. We have to initialize again. So you can never forget to initialize because Terraform tells you. All right, and then apply. So we improved our template, and I expect no differences. In the meantime, we are going to have a look to the state file. To the state file. Oh, he doesn't like it. I have to wait because he's using it.
No state file for you.
No, indeed. Oh, there he goes. So indeed, there are no changes.
Yeah.
So that's fine. So let's have a look at state file now. So this state file contains everything that Terraform needs to know about the provisioned infrastructure. Actually, you never have a look to this file in detail, but it could be handy to know about it. But at least one thing that you should know is that everything that is provisioned, all properties are here. So I have the storage account. This is the role assignment. Here's the storage account. And one thing that you should note is that, for example, all properties are here. So also the secret properties, the access keys, the connection strings. So actually, I'm using Terraform now here on my local machine with a default initialize, but you should not use it this way. First, because now secrets are here in this file. You could add it to Git, but that is not a best practice. You should not add this Terraform state file to Git. But how can you work with multiple people then? Well, that is a concept that is known as the backend. So we can configure the backend of Terraform with backend. So now we are telling for the Azure RM provider to configure the backend, and we specify which storage account, which container, the key, and in which resource group the storage account is located. So sometimes you have to initialize Terraform again, and he will tell you that is in case of new providers, a change in the backend, or modules. And so we have to initialize Terraform again now. Terraform will notice that we have a new backend, and he will ask us if he needs to move the current state to the new backend. So that is what he is asking here. And yes, I want to have that.
So that state file, Pascal, does Terraform use it to make a diff and to find out what it needs to do to update the environment, or does it also look at the environment itself?
No, it's mainly looking in this Terraform state file. That's the truth for him, for Terraform.
Okay, so you should be careful then not to make any changes using Bicep or manually using the portal.
Indeed, if you do
this, will
this,
be out of sync. Yeah.
Yeah, if you do this with other technologies like Bicep or ARM templates, the CLI, but also manually in the portal. There are Terraform commands that you can refresh your state again. It's called refresh.
Okay.
Yeah. And to show you and now I've shown you what a disadvantage the state file has. It has secrets, so you have to be sure that the access rights on your storage account are configured correct. For now, we moved to the different backend, so we don't need this state file anymore. I will delete it, so we don't have it anymore. We are making use of the Azure Cloud now. What is an advantage? Well, if we remove, let's say, the role assignment again. Yeah, that's enough. We are going to apply now. And that is the big difference between other technologies. Because Terraform will notice, based on its state, it is looking to the differences indeed, exactly what you said, Sander. And now we will notice that he has to delete the role assignment. So if you ask me, Terraform is the only real desired state technology. Because if you were using ARM templates or Bicep, then, and if you remove the role assignment, well, the role assignment would still be there in Azure, unless you use the complete way of provisioning. But not many people are doing that. And indeed, he's going to tell us that one item will be destroyed, and this is the role assignment. So yes, we are going to apply this. So this is a unique feature, if you ask me. So let's go to the next step. Because we have some hard-coded values here. And of course, if you want to use this template for multiple environments, for example, then we would pass a different name per environment. So let's make this a variable. So we are going to add a couple of variables, in this case for the resource group name, the storage account name, and the tags. So now we can use this is the resource group name, part of tags, and the storage account name. So the name is maybe a little bit misleading. The name in Bicep is a better choice, parameter, because this is a variable. You can also use variables, of course, in Terraform, but there is a different keyword for that, and that is locals. So now we have added the variables, but we need to pass the values. So if we are going to add, let's say, nonprod.tf vars, and we have the values here. So this is our environment-specific values file now, and we can pass this to our template. We do it like this. And yeah, again, we will not have any change when we apply this because the values are exactly the same. The next step, because we can reuse our template now over environments, but for example, this storage account here, maybe I want to provision multiple storage accounts, or we have multiple teams for a customer or for your employer, and you want to reuse this storage account. So you want to create a template of it, and that is called a module. the same as in Bicep, for example. So what we can do is still applying. I'm not sure if I'm going to change this resource if he likes that, but we are going to try because otherwise it takes too long. So we are going to create a module, and I've added a module here in the directory storage account. And this directory storage account, contains now 3 files, 3 TF files. One is the main, which contains just the storage account, as we saw earlier on in our template. The variables that we also saw earlier on. And a new keyword, output. Because this is a module, we could use some output variables to reuse in other templates. For example, a connection string or the name or the ID, that kind of things. So I have referenced this module here now. I can create it, I can give it the name that I want, in this case, again, storage, but I have to specify where this module is located. It's the storage account, the directory here. And then we fill in the known properties again. If I'm going to apply this, and I will not do this because it takes too much time, but you have to believe me, then Terraform will notice that the storage account is gone, so he will delete it. And he will notice that we have added a reference to a module with a coincident name to storage account with the exact same name as we already have provisioned. So he's going to provision it again. And that is something that you have to know about Terraform, because you not only have to refactor your code, you also have to refactor your state file. We can have a look to the state file at this moment with Terraform state list. And we'll see, of course, 2 resources, one for the resource group and one for the storage account. There they are. The name of this storage account is changed. Actually, that is the only change because it's the same storage account. So what we have to do now is we are going to call Terraform state and then move. We are going to move from this state to the new name. And now there's only module dot. That's the only addition that is needed. But we have to do this. And if we don't do this, well, then Terraform is happy as well, but I'm not, because he will delete the storage account and create it again. So now if we are going to apply Terraform again, you will see no changes.
Quick question about the deletion, Pascal. If you put resource logs on your storage account in Azure, does Terraform respect those, or will it simply delete those logs as well?
Yeah, good question. Actually, I've not used Terraform with logs yet, so I'm not sure, but I think he is able to manage it, but only if you really want to. So I think what we saw in the provider is that you can add features, and I'm not sure, but I guess we can add a feature how to deal with logs. So, but I'm not sure. Nice question. Yeah, again, I have added a module, so we have to initialize Terraform again. So you have to initialize again when change for the provider, for the backend, or for modules. Okay. And now you can apply, and there will be no changes. We can go one step further, because now this module is located here in this directory. But what if you want to reuse this module over Teams? Well, then you could do this. I have uploaded this exact same module to my GitHub repo here in storage account. And we are referencing this GitHub repo now instead of the local directory here. So again, we made a change to this, to the modules. So we have to Terraform init again. But if you apply again, there will be no change again. So this way you can reuse Terraform templates. And this was a very simple template with only a couple of properties, but this could be much more complex. Had to really use a storage account with shares and containers and access rights per container or share, that kind of things. So here we are seeing indeed there are no changes. I can apply this again, but the result will be exactly the same. So this is the demo from nothing, from an empty demo.tf file to what we have now. So I've shown you how to provision resources, how to make use of existing resources, what the advantages are of the state file. The Terraform knows a lot about your environment. It is really the desired state. He is able to delete resources if you remove something from your templates. And there are also disadvantages. You not only have to refactor your code, but also the state. And you have to make sure that your state is safe, in this case in the storage account. It's very easy to reuse code using Terraform, and that's very powerful. So hopefully you have a good idea now what you can do with Terraform, and hopefully it was a nice introduction for you.
It definitely was, Pascal. Nice. So this is all open source, right? Have you ever added a feature yourself to Terraform?
No, I wanted to, because I was missing a feature, and I thought, well, it's open source, so let's not wait for Microsoft. Let's do it myself. But when I wanted to add it, I was looking into the code, and I found the property already. So someone was faster than me, and I just had to wait for the release.
They beat you to
So
it, yeah.
Either way, your problem was solved, right? So,
yeah,
what kind of programming language is it anyway?
they write it in Golang.
Ah, okay.
Yeah,
cool. Well, thank you so much for telling us about Terraform. Just as I'm kind of the same as Edwin. If you look at infrastructure as code, I use Bicep a lot, so it's very interesting for me to see these differences with Terraform. I really like what you did with the different providers, that you can use Azure AD provider, get some data from that, and then use that with the Azure provider. And of course, it also works across clouds. So yeah, really powerful stuff. So thank you so much, Pascal, for joining us.
Yeah, thanks.
You're welcome.
Those of you watching, I hope you enjoyed it too. And if you like these episodes, don't forget to press the subscribe button, and we'll see you next time.
Bye-bye.
Bye-bye.